Welcome back, folks. In this session, so far, what we have done is we have done the drying up of the tank, we have done the inerting of the tank, we have done the gasification of the tank, and we have also done the cooling down of the tank. Very shortly we will be going back onto our simulator mode because we have already let the tanks cool down. So we are going to go back to our tanks and see how our tanks were doing. So we are giving it the time for cooling down before we start loading. So in the meantime, we are discussing the loading. What are the things we should do prior to the loading? Folks, I've told you earlier that whenever we are loading, we are also discharging. So once we are loading, we are discharging. It means that we are discharging the vapor. Otherwise, if we do not have the discharging facilities during loading, we will have to reliquefy our vapor and they need to put it back into the tank. So return to shore is a normal procedure. But let me explain you that this happens on a big ships. But if you are on a small bunker barge, you may not have, you may have to reliquefy your own vapor. So in that case, of course, return to your own reliquefaction plant, reliquefy and throw it back to the ship. So for the loading, we are simply taking the liquid from the shore and putting it down at the bottommost part of the trellis. And then from the top, we are taking the vapor out directly. If the shore can, receive our vapor comfortably. Otherwise, we might have to blow the vapor to them. So again, the same sequence which we have adopted during the cooling down process. We take the liquid from the shore, pass it through Chickson and drop it down at the bottom part. So, and we give the vapor back to shore for reliquefaction or liquefaction. If they do not have liquefaction facility, some of the terminals just flare it up. They burn our vapor. Nowadays with emissions controls, all the terminals are trying their best to reliquefy the vapor because of course it is money, it is cargo. So they will reliquefy and put it back into the tanks. Microphone. Yeah, so folks, what we are trying to do is we will take the liquid from the shore into our tank and we return the vapor to the shore. And of course, we need to blow it off, so we'll use our compressors to blow it fast to the shore because the vapor may be in bigger quantities. So again, if we do not have a vapor return line, then in that case, what we will be doing, we will be taking the vapor to our reliquefaction plant. From here, we are taking the vapor to our reliquefaction plant, and through the condensate return line, we are throwing it back to the tank. And of course, the vapor return line will be just blanked off. So we have both procedures available on the ship, but because reliquefaction is a relatively bigger challenge and it involves a lot of energy for reliquefaction, we normally, most of the plant, we give it to the shore. So loading without vapor return line, we will not use it. We will, in fact, what we will do is we will take from pass it to the compressor, to the cooling cascade, refrigeration, cooling, and then we'll put it back to the tank. So loading a fully refrigerated storage jetty, long distance between shore storage, ship and high ambient temperature can cause pressure remaining problem, especially in early stages. So loading rate must be reduced to give time for reliquefaction, plant for cooling down, cargo tank, etc. Loading to be limited to the quantities of liquid into the tank via top space, and of course helping condensate some cargo. So normally this was for the on non-pressurized vessel. But type C tanks are, we see type C tanks very often on the bunker barges. So normally in those type of the bunker barge which we have seen on the our Viking Grace, then with that type of vessel need to load under pressure. So need vapor from shore to purge the remaining nitrogen and constraint from the tank to equalize the pressure between ship and terminal. And then tank and pipelines temperature must fall below design temperature. And once our tanks are cooled down, we start loading at a slow rate in the beginning. So the tanks are suitable for minimum temperature, no problem. Those tanks get cooled very quickly, and they are designed to sustain a high degree of thermal gradient, and of course they are designed for these kind of things. So cargo should be heated, pumping through a cargo heater on board, and once it is done, attention to be paid off to maximum at 98% at maximum temperature reach during the voyage. So now, since we are talking mainly on the experimenting or exercising on membrane tanks or NO96, etc., the filling limit is also one of the biggest issues. How much we may be able to fill. So in that case, on an oil carriers, chemical carriers, 98% is the rule of thumb. We fill. But IGC chapter 15, 8.2.17 says if the vessel is 15 degree listed or 0.015 of the length as a trim, the ship can be filled over 98%, i.e. in that case 98.5, because now you can see our cargo dome is still empty, so it cannot overflow. Why we are doing it more filling than 98%? Because to avoid the sloshing problem. The lower the cargo level, there will be more sloshing problem. Now, the filling limits of the MoS-Rosenberg. MoS-Rosenberg or spherical model, these filling limits are comparatively higher. Why? Because of the design. In the membrane design, you can see there is lot of free surface area, and all that area, the larger the area, the more the evaporation, because the evaporation happens from the top of the surface. So then if we reduce the evaporation area, then of course there will be less loss of cargo, less problem. But in a gas, in a spherical tanker, you can see the surface area of the liquid is very less because of the tank design. So even if the ship is listed 15 degree on one side, there is not a significant change as compared to the membrane tank, where we have a chance of overflowing. So IGC code chapter 15 again said in its rule 8.2.17, 15 degree less, 0.15 L trim, 99.5%. That is a good news, folks, isn't it? We can fill MoS-Rosenberg vessel up to 99.5 because it is a low density cargo. It is less than half the density of the waters. We can put more. Weight is no problem for carrying, so we can fill it to 99.5%, and by filling this amount, we can have lesser evaporation. So that is about the filling. Now when we are talking about the subject of loading, we need the information about the loading. Normally it is the Saab tank radar we have got in most of the vessels, but many other manufacturers have also made the similar technology. Without going into the details of all the things which is fairly evident to you, I want to focus on this area where there is a radar beam and radar beam is passing, and that radar beam is passing through a channel, and in addition to that there are multiple lines or multiple small pipes are going to sense the temperature at different level, and also we will measure the pressure also in the tank, and all this information is electronically going through this line somewhere, the cargo control room. So here you will be able to see this. Here is the radar beam which is guided through the pipe. We have multiple sensors ending on different levels to sense the temperature and pressure, if pressure sensors are fixed in. But the problem now is very interesting, that this beam comes down to the pipe, from the pipe, and if the tank is nearly empty or empty, it will reflect from down. Fair enough, we will get the reading. But what if the tank is 50% filled? The radar beam can penetrate through the liquid because it is a colorless, odorless, transparent liquid. Radar beam can easily travel through, and what it will do, it will come and hit the bottom, and we will have another echo. One from the surface of the liquid, one from the bottom of the tank. And that is an undesired situation. We do not want to know how far is our bottom, our tank bottom. So in order for this, the engineers have come with a very good idea, that they have put the spiky kind of thing, which is, and what they are doing is they are deflecting the energy in different direction. And you also may have noticed that this is the thermometer, thermal sensor for sensing the temperature. There should be two. I think the other one is on the other side. So technically this is one thermal sensor, the other thermal sensor, and they are sensing the temperature at the bottom of the tank. The bottom of the tank temperature is very important to us because this is the temperature. If our tank bottom temperature has come to nearly in the cooling down process, if it will come nearly to our cargo temperature, then we will be able to start loading the cargo. This is what we are going to see in our exercise now, that how this thing is happening. So this thing here at the bottom, it's called the radar beam deflector, and its job is to not give you the sounding or not give you the LH of the bottom of the tank. Now another furniture of the tank which is fitted outside of the tank, which is a relief valve. All pipelines and component, the IGC code chapter 5.2.1.6 says that all pipelines or components which may be isolated in a liquid full condition should be provided with a relief valve. Okay, so on LNG carrier, these usually relief back into the cargo tanks. In old vessel, it was used to just go into the atmosphere via a knockout drum. These may usually set to lift at 10 bar pressure, but again, different manufacturer, different tank design. You will have your own pressure. Very simple, high pressure coming here. There is a gasket here, and these are a spring which is holding it under the pressure. The disc, if the pressure exceeds certain, and it will press this and get relieved from the pipe. Now, at the same time, when we are loading, we are doing the simultaneous ballast discharge operation. So I will show you that in a minute. Let me go on the simulator. Yeah. Is the mic on? Can you just check if we are hearing well? Okay. So what we are doing here is that we have shown you that we'll discharge from the system, and what at the same time when the tanks will come to the stripping level, we will do the stripping from the tanks, running the stripping system, which I'm going to explain you while we are doing the deballast. And now cargo refrigeration and reliquefaction at sea. Once we have completed the loading, this is one of the things which we talk about as the boil off gas management, which I'm going to talk shortly. And now I'm going to start the simulation where we are going to witness the how we can do the completion of cooling down phase and start the loading of the tank. So folks, this is your, I hope now you will be able to see the simulator. And now what we are doing is we have updated the system. Now you can notice our exercise is running, and we are doing the cooling for very long time, obviously. Now let's see what is the condition in our tanks. Number one thing, we will have to check why we have got a nitrogen alarm. Let's go and see. What is happening? Low secondary insulation is header pressure alarm. Okay. Primary insulation is space header pressure alarm. So did you notice that our pressure in the tanks have interbarrier space has reduced? Why it has reduced? Because our tanks have cooled down to such a low level. Can you see at present our tanks are cooled down to minus 120 degree temperature. We are getting the liquid from the shore at about minus 161 degree temperature. And why it is sprayed in our tanks, it is it has gone to such a low level. Now once the tank pressure, the tank is shrinking now. Okay, excuse me folks. So the tank is shrinking, and tanks are shrinking, and the interbarrier spaces are getting cooled. So interbarrier spaces are definitely going to have a low pressure in the interbarrier spaces around the tank. So what we want to do is to start the buffer tank. And now we have started the nitrogen generator. Our nitrogen generator is working, and in a little while our pressure in the tanks will be okay, so let's increase we can either do it automatically, or we can also do it manually. So we can increase the set point, or we can open the valve lightly. So to increase the pressure, at the moment it is minus pressure, and we definitely want, this is a very undesired situation. Now the pressure will slowly increase in our interbarrier spaces. Okay, so now let's go back to the tanks. This is our number one tank, where top is minus 120.1, the bottom is minus 120.4. Reasonable thing. The tank pressure is about 13.3 kPa. Let's go to tank number 2. Tank number 2 is a very good condition. Minus 134, minus 135. At the bottom minus 143, ideal for loading. Did you notice that um, uh, that the tanks are on the second number tank is comparatively more cooler than number 1 tank, and the third tank is further colder than number 1 tank. Why number 1 tank is less cooled is that because number 1 tank has got a forward cofferdam and there is no tank in the side. So mind that whenever we cool the ship, we are cooling the tanks also. Not only the tanks, we are cooling the outside environment also. That is why we have got a low nitrogen pressure alarm. So fair enough, we are getting the cooling, we are using just one spray header. Let's go and check number 4 tank. This is our number 4 tank, and the bottom temperature about minus 139. So we have managed to cool down the tank to minus 140 degree temperature. So, and now you may notice that there is a very little sounding, about 0.003 meter. So about 3 millimeter, which is while we are spraying from the top. In the beginning, the cargo or LNG will diffuse very fast. And once it is diffusing, it is while it is falling down, it evaporates within this region. But once the temperature is on roughly minus 140, some of the droplets may not be able to evaporate altogether, and they will fall down and they will start collecting on the bottom. And this is the time when we see the sign that yes, this is the time when we can start loading. So let's see number 1 tank. We have about 3 millimeter here, the bottom one. So let's see what is happening in number 1 tank, which has got a slightly higher temperature. It is minus 120, and there is no indication of any liquid at the bottom because the liquid is diffusing while it is in here. So at the moment, there is no drizzling in the tank which can be accumulated at the bottom. So technically, number 1 tank is not ready for loading as yet. So if we continue and we go on number 3 tank and see what is the condition there. In number 3 tank, you will see it is minus 138 and about 2 millimeter of cargo, or very little cargo. Of course, they start the boiling and it is still taking the heat from the other spaces. So now, going back to number 4 tank, we can start loading in number 4 tank. Because yes, it has got about 3 millimeter of cargo. It has already reached now minus 140 degree point. Ideal thing is that we should have minus 160 degree temperature in the tank, where technically rather than diffusing the liquid here, we will have a kind of liquid shower or liquid drizzling or liquid rainfall in the tank. And when this rainfall starts, this is the right time for loading. Now, let the tank cool down more. Now we want to start the loading. Once we want to start the loading at this stage, it is very simple. We will open the give the liquid to the liquid line and start loading from the bottom very slowly and gradually. Hmm? So, but if we, but at the same time, we should be able to start our compressor. So let's check if the compressors are ready. Hmm? So let's put both of the compressors on standby. Uh, we can see the glycol is running there. We can see there is a nitrogen pressure already built up, and we can see that we have got the vapor return line ready to send the compressor to the vapor to the shore. Okay, the vane angle can be controlled from here, from different point. For example, I want to bring the vane to a certain lower level, then I can adjust it accordingly. Okay, so from here now you can see the vane angle is here, and so anyway, folks, you understand that this is how we'll manage the veins on it. So technically our vapor is coming here, going through the bypass line and going to the manifold. Okay, now we will put the vapor through the compressor and pass it on to the shore. Okay, so let's start the loading, and at that stage, because your lines are already cooled down, but again, before we start full loading, we also want to see what is our tank environment, what is inside our tank. So let's see it. Take a portable gas detector, and can you see now carbon dioxide in our tank is 0.18.
We take a portable gas.
Yes, for this one. We have a fixed gas detector,
Yeah.
but we can take it from the fixed gas detector. But on this panel, we have the gas portable gas, because we are testing the environment here. So we want to now detect the hydrocarbon by volume, not LEL, because we are sure that we have put so much of liquid inside. So, so our oxygen analyzer is saying us, let's um, purge the system. We have purged the system. Let's check O2 content. We are going to load in number 4 tank first. So let's see how much is the O2 content on the top. 0 O2. Okay. Switch off the oxygen analyzer. Purge the line. And now you can also see the carbon dioxide is really negligible, 0.03. So now there will be no chance of sublimation of carbon dioxide. So let's go and check it here. The hydrocarbon. And purge it out. The first loading after the dry dock is always very tricky. Okay, so let's check. Actually, we have not done the spanning of this, you know. Let's check here. Okay, 0.02 reading. Air again, spanning it. Switch it on. Check in number 4 tank middle point and see how much it is. The gas, you have got 99.82% by volume. It is in the middle of tank. So technically it is 100% of gas inside it. You have got carbon dioxide negligible. Your dew point is minus 80.1. So technically this is the ideal condition for loading the tank. Let's see the tank condition. It is okay. So now let's set up the line for giving it to the shore, or sorry, taking it from the shore. So very slowly we will open this line. We will not open it fully in the beginning. We'll open it 10-15% because we want slowly to put the liquid in our liquid header. Okay, then what we will do is we will open this valve very slowly. We want the liquid to be introduced in the tank at a very slow rate. Because again, when it will go inside the tank, let's check again. The liquid coming this way, going this way, and going into the tank. Now slowly and gradually increase. And at this instance now we will be able to ask the shore to increase the pressure on our lines. Can we see we have got a very little flow, just about 41 cubic or 43 cubic. So we will ask the shore to give us more liquid. Yes, ship 1, the flow for loading has started. We will call this time 16:30 for loading.
Roger that.
Can you confirm you are receiving the cargo in your tank?
Yes, it has increased. We are receiving.
Go to the tank. Can you confirm it manually from the tank level?
Waiting for.
No, these are pumps outside.
Yes, we are receiving the cargo.
All right, Chief. Good luck. continue. Let me know if you want me to increase the liquid.
Okay.
Did you notice how quickly the temperature, bottom temperature has changed?
Yes.
All the way up to the top?
Yes, sir.
Because now it is boiling off. What is the pressure in your tank?
14.2. It's increasing 14 to 15.
It is now increasing. So we will shortly start our compressors. Can you start loading in your other tanks also? Go number 3, 4, 3 and 2 tanks. Now on your manifold, go to the status. Can you see you have got 62 kPa pressure? Now you can ask the shore to open the other manifolds and supply you with the liquid, because now you have got more tanks open, and you can first you open your lines and then ask the shore to increase the liquid flow. Once everything is settled down. This is normally a very critical time for the ship. Go and check the pressure in your tanks. No, there is no need to join it. It's already joined from there. Your tank pressures are still manageable. Can you see the liquid on the checksums? You are getting the liquid on all the tanks. 26 centimeter in your number 5 tank, 4 centimeter in your number 3 tank, 4 centimeter in your number 2 tank, and 1 centimeter in your number 1 tank. Of course, number 1 tank is making more vapor now because we have started it. Now can you see your spray headers are showing all minus 161. Vapor mean forwards are showing that right. Okay. Now in the next stage we will do the cargo compressors,
HT compressors?
Yeah, HT compressors. At the moment, leave it like that, or maybe you can increase, put it on auto, the compressors, or just leave it at the moment, because the pressures are not so high, it will create a vacuum in the tank. So we do not want it at the moment. The tank pressure is okay, reasonable. So now, can we leave it aside for a little while? And what we will do is simultaneous discharge of ballast will start. Okay, because we want to get rid of the ballast, because we don't want water to get cooled so much, because of course that water is not so far from. So maybe looking at the stability condition, you can start certain tanks, not all the tanks, because we do not want too much of free surface effect. So maybe a couple of tanks from forward, couple of tanks from aft, and once they are done looking at your condition of stability, because now you are loading in the center all four tanks, so you have a choice of discharging from anywhere. Keeping an eye on the draft, you have got a positive trim of 10 centimeters.
This is a different ballast.
Yes, this is a different. This is an NO96 ship. We have put you on a different ship. Yes, that is the challenge, young man. That every time you go, you may go on some other ship. You will not have exactly the same lining system or the ship system. So take it as a challenge. Think about it. Now I'm sure you are capable enough to discharge the ballast. You can discharge it from up. Keep on discharging and keep an eye on this thing flickering.
Why it is not opening? LNG is quite specialized. I've done oil tankers and chemical tankers and bulk carriers. I mean, crude carriers and chemical are tedious. I mean, even in crude, if they have good big VLCCs or something. But LNG is something a little more specialized.
Yeah.
Especially with LNG being so carcinogenic, not cryogenic, that they make the steel go brittle.
Is it going out?
Yes.
Liquid?
Yes.
What is the condition of your tanks?
Tanks are also getting the cargo.
Your tanks are also getting the cargo.
But very slow.
At the very slow rate because you didn't ask the shore to increase the rate. So just ask the terminal to increase the rate. Have you opened all your checks now?
Yes.
Can you recheck it, please?
Yes, sir. Three. Okay.
And as soon as they will start, now you will have to look forward for starting your compressor.
Yes, sir. All the valves are open now.
So see the flow, go to manifold, go to see the status.
Yeah.
Huh?
It's increasing now.
Increasing, the back pressure is increasing.
Yes.
Huh? How about your liquid level in all the tanks? Are you monitoring this one?
Yep, it's increasing in 2 tanks.
So see where you haven't opened the valve to these tanks, so why the liquid is going there. No, that is your pump valve. Can you go on the main line? That now I don't think you require the spray heading.
No.
So can you stop your spray header?
These valves are okay.
Yeah, all the spray header, gray line, stop. Separate the gray line from the main cargo line because now we have completed the cooling operation. Because your temperatures, all of them are now minus 161 degree. You are getting cargo now in
Yes.
your forward one.
Yes, sir.
So the moment you have stopped the spray headers, isolate everything on the gray line. Yeah. Now the liquid line will be going there. Remember we should drain the lines whenever we are using these lines, and we prefer not to leave any cargo in between the lines. Yeah. Close it. Close this one.
This one?
You want to close this one because that is you are connecting. No, not this one. This one. Yeah.
Okay.
Because these are your manifold valves. These are your main valves, and now your condensate line is separate. Now what you will have to do is just open this valve and drain. Very slightly open the valve and drain it. Now see the condition of the pressure in your tank. Very shortly you are going to get the high pressure alarm in your tank, and we are going to start the compressor. Show me your compressors. No, show me your deballasting. Is it going away?
Yes, sir.
Okay, lovely. Okay, you're using one pump. Your pump is not shunting. You have got a good discharge pressure. Well done. I'm happy. Can check your temperatures and pressure of all the tanks from number 1 to 15 kPa, 15.7.
This is quite high, 9.
Yeah, because there is a boil off going on there,
Yeah.
Because you remember the number 1 temperature was slightly higher.
Slightly higher.
Normally we should not have done at that temperature. We try to bring the temperature as low as possible because of the time constraints in this simulation. We will have to do it. So now you have got around 14 centimeter cargo here, 9 centimeter here, 5 centimeter here, and we can increase the flow further. Can you check the back pressure on your manifold? Chickson arm, 83 kPa. Your vapor is going out with minus 153 degree temperature, not too much of pressure, very comfortably. It is going out. Happy? So, folks, all of you have got the message very clear now that how we complete the cool down operation and how we start the loading and how we, at the same time we start the deballastings of our tanks. You can start the compressors now. Just run one by one, just run this compressor at a very low level. Run this one first, one by one. Yeah. Nitrogen seal pressure is okay. Put it on auto, so it will automatically, manage. The set point need to be increased a little. Yeah. You will see on auto. Oh, it need to go to 60% load, then it will automatically come. Now you may have noticed that this valve has automatically closed, and now the compressor is taking suction and putting it off. Can you see the flow? 20. Yes, can you change the vane angle now and see? Yeah. And watch here. Is it increasing flow or decreasing?
Decreasing.
So it is not a good idea. So go back there. Now try to put it on auto. Set it here. Set point. Yeah, little up. Yeah, okay, that's fine. Open. Yeah. Yeah. Put it here open. And put it on auto now. That is fine. You can start at the moment the other one and let the flow. You will have to now see your tanks are not going into vacuum. Okay, that is a very important thing. Set point. Okay. Start the second. You already put it on. You see, your compressor has started. The gas is going out. The valve has opened under pressure. Okay. The other valve has closed where your cursor is. Okay. Now put it. Can you see now flow at the discharge point? You can see there is a 35,000 cubic meter flow. Okay. So maybe it is way too much. Check the pressure in your tank. We do not want to vacuum the tanks. Pressure is okay. You haven't got any alarm here.
No.
So, young man and folks, you are also very well settled in the tanks. Monitor all the tanks from 1 to 4. It is okay?
Yes, sir.
Minus 161 degree temperature, 20 centimeter the sounding, pressure is okay, 0.6% fill, the liquid is going okay. Are you happy with this arrangement?
Yes, sir.
Hmm? Now, because the gas is going out from there, can you close this valve in the middle? This is very important that all unnecessary valves need to be now closed, because now you are not giving condensate to the. Happy, because this is what we have opened for draining the valves. You remember?
Yes, sir.
Draining the line. Sorry. It is okay. There are only 4 tanks. Happy?
Yes, sir.
Discharge is okay. Loading is okay. So now you need to confirm with the shore that you are doing very well, and that is we will let it load over a period of time. Once the ship will come to the topping off point, we will start topping up the tanks, and of course we keep on deballasting the tank. Now maybe you can start more deballasting of the tanks. You can start the other pump if you want to, please.
Already started, sir.
You have already started. Well done. Other folks, how well are you doing? Okay. Okay, folks, I will let it continue, and we will go on our presentation mode, where now I will talk to you on the further stages of loading. We have already discussed that. Now, just a recap again before we go on our presentation, that we have so far managed to do the drying up of the tank. We have done the inerting of the tanks. We have done the gassing up of the tanks. We have done the cooling of the tanks, and we have also done the the loading of the tanks. Now, the things which are remaining is the topping of the tanks and the discharging at the other terminal or the port or wherever. So let's now press on. We have talked about the deballasting. We have talked about the reliquefaction at sea. Now, when we are going at sea, after the completion of discharge, we need to do the cargo refrigeration at sea if we do not have a boil-off gas arrangement. So what we will do is we run a reliquefaction plant. We should never run a compressor during heavy rolling and pitching because of the sensitivity of the vanes. Condensate is passed through the top sprayers, cooling down, and of course liquid has to be cooled. To cool down, bulk of the liquid condensate return should be through the bottom of the connection of the tank to ensure proper circulation. So reliquefaction plant run at more than one tank simultaneously. So control condensate return to avoid overflowing on the tank. So what basically you are doing is you are taking the vapor, you are reliquefying it, and you are sending it to the tank. But imagine if you are just taking the vapor from all the tanks and condensate you are throwing to just one tank, the tank might get overflow. So you will have to return approximately whatever you have taken from one tank. So at the same time, when we are doing, we will also have to do the at the sea if we have got any ballast exchange to do. We have already done the ballast exchange when we were coming to the loading port. Now we are loaded and going to the discharge port. So there is hardly any unlikely to do any ballast, but if we have any ballast which need to be exchanged, we should exchange. So this is what you were managing early. So always follow the ballast plan. Deballast tank adjacent to tanks being loaded. Why we are doing it? We do not want our ballast to turn to ice, if it goes below 0 degree temperature. Always check stability every hour. Now we'll come to the cooling operation, and we will discharging operation, and we will talk about the discharging operation when we will complete the loading operation. So just wait a couple of minutes, folks. Folks, I'm going, at the moment I'm operating the terminal, and also I'm going to um, load another exercise where you are going to experience the final topping of the tank and completion of loading. So there we go. Okay, folks, here we are. We have started the loading, and now we have come to the point where our flow rate is around 3,100 cubics on each of the manifold. We have got 4 liquid line connected and a vapor line connected. Now our draft in loaded condition is 10.55 meter forward and 10.72 meter aft. Our rest of the other things are doing very well. Now we have got certain alarms. So let's check at the topping of a stage what are our alarms. So let's see the ballast alarms. They are all, we have stripped the tanks. We have hardly anything in the tanks, so we have got these pumps running. So we are about to go to a point where we are. So those tanks which we have already stripped and they are empty, we will acknowledge their low level alarms. So we are not, being distracted by the other thing. At the moment, we have got these 4 tanks being discharged. This tank has now complete stripping. So we'll close this valve. This tank is nearly completed. So stop and close this valve, and acknowledge the alarm. Happy, young man?
Yes, sir.
So now all these tanks are virtually stripped. We have got only last tank remaining, which have got around 11 centimeter of the cargo, of the ballast. We'll try to ballast it or deballast it altogether. We have a little ballast here, which we have kept intentionally for some later stage. Because our draft trim is already about 20 centimeter, just over 20 centimeter aft. So we want to keep it for the balancing of the ship. But later, at any stage, if we want to discharge this cargo, discharge this ballast, we will be more than happy to do it. But we normally want a very low level. We can see we have got just 44 cubic, 36 cubic remaining in this tank. So let them strip out.
So we've kept the ballast on the front, in the forward. Normally we keep the ballast in the aft, right?
It depends on the LCG. See, we have got a new low level alarm. We will acknowledge, yes, we know that our tanks are stripping. We have got 28 cubic, 27 cubic, 20 cubic. It is going away.
Yeah.
So now I have acknowledged all the alarms. So I'm expecting that my ballast page, ballast control panel is fairly steady. Okay, just wait few minutes. It is stripping the last bits out of the tank. We can stop this tank as soon as it will touch nearly zero. So stop, close this tank, and now we can stop one of the pump. Okay, so switch off this pump and of course close the valves immediately. So so now you can see this pump has stopped, the discharge pressure is released, and now my other tank is also coming to zero. So I'll close the valve and I will switch off the pump. So technically your operations of deballasting has completed. We have in all tanks 000 centimeter sounding or millimeter sounding. We have got no cargo in these tanks, so lesser level of water is more dangerous than the higher level of water. Reason being, lesser level of ballast can freeze. Higher level, it is very difficult to freeze. So that's why we have kept this cargo in order to maintain our trim. We have got 10.6, 10.3. Now we have got a cargo tank alarm coming. Let's go quickly and see the condition of the cargo, which tank is closing. At this time, we will ask the shore to slow down the cargo. Just we will slow down cargo. Bear with me for just a couple of minutes. We can mm, see the cargo tanks here. We have an alarm from the tank. Level is getting high and we need to be standby. So I'll ask the shore to slow down the cargo and we can individually measure the tank. This is the tank level we have got in this tank when come in. So we are more worried about number 4 tank. So let's see what is in number 4 tank. Are you happy?
Yeah.
Come on, say loudly.
Yes, sir.
So can you see we have got some room in this tank? We will decide what is our final ullage earlier on. At the moment my tank is 94.7 filled. Okay, and we will ask the shore to slow down the cargo now, because for topping off we need to slow down. This is again a 94.5. Let's see our forward tank. If you have got too much of trim, that's why we have got little ballast in forward. If you have too much of trim, then of course your number one tank is the least one. Okay, so first tank which is going to top off is your number 4 tank, which is now nearly 95% filled in. The tank pressure is running okay. So now can you see we have got a high tank pressure alarm. So let's go and check our compressors, how well they are doing. We have got the wind set to -6.5 and flow of this. So we have this tripped. So we need to start this compressor. Okay, yes. So the flow will go out more faster. Can you see now? Here the flow is increasing. So you see these alarms are very important for you. Now this bypass is closed and you can see the flow of to the shore will automatically increase, and after a little while, because now the pressure is normally always you get the pressure alarms. Now you can see the pressure should drop here, or at least maintain on the same level. Still going high. So can you see the pressure relief valve is opening, which is not a very desired situation. So what we need to do, we'll need to slow down the loading. So just call the terminal.
Terminal come in?
Yes.
We need to slow down the loading. We need to slow down the topping up.
For the topping now?
Yes.
Okay. I'm trimming down my tanks, and also I'm trimming down my cargo. All right, my virtual learners, I will take a leave from you here at this moment, and I'll pay attention to my local students here, because they are coming on a very critical stage of topping off, and I'll let them top off the tanks, and I will be working on the terminal control stations where I will be adjusting their flow rates to different ships or different workstations. So we will take a leave from you at this stage, and I will just pay attention to the others